Okay, now let's talk about the third type of ion that we can get. These are the transition metal cations. And I put down that they're cations because they're always cations. All metals get positive charges, all metals turn into cations. The thing that's different about the transition metal ions, you'll remember that those are these guys that have put an X on right here. It's not that they don't form ions, it's just they didn't follow these rules. Okay. But, so they don't have any rules. Um, One thing about them is that there are no rules based on the column. Another one is that there's more than one possible charge. I don't know if you remember way back at the beginning. Let me go back to the beginning over here. Showed over here. Iron over here has a +2 charge, but then there's another iron here with a +3 charge. That's because iron is a transition metal. And there is more than one possible charge. How does that happen? Well, a lot of the when transition metals are filling their or their electron configurations, um, their electrons are going into a D sublevel, but they've already filled an S sublevel ahead of time, a sublevel uh, from a higher electron uh, energy level. So there's already two electrons um, in the valence shell. So +2 is a very common state because that's transition metal losing the S electrons that were already filled before its D electrons started getting filled. But sometimes it can lose um, an extra one, sometimes extra two. Really depends on the conditions of the how many D electrons are in there and its conditions. So um, there's no general rules. How do you know what the charge is? We're going to have to. Here's the nice thing: we're going to give that to you. You don't have to figure out what charge any of these things are. Okay? Any of these transition metals are. This here is called the periodic table of ions. And I didn't show this to you before because I wanted you to be able to at least do um, the main group elements without using this, but with using a general periodic table. Because you won't always have this. This is very actually kind of sometimes hard to find. It's not ubiquitous, not found easily, like the periodic table is. But you'll notice here that it follows the rules. Here on the this periodic table shows the different elements with their ions. So everything in column 1 has a +1 charge. Everything in column 2, +2. Everything in column 13 pretty much +3. Right? Boron sometimes has a hard time forming ions, but if it did form ion, it would be +3. Uh, this one you'll notice as you go further out here is +4. Well, these are -3 up until we hit the metal non-metal transition line. These are -2. These are -1, and these don't get charges. So they follow the rules we just showed. Okay. The reason I showed you from the blank periodic table over here is because a periodic table like this, well, without the markings, is much more common. So you should just be able to look at a periodic table and be able to know, oh, everything in this column gets +1, everything in this column gets +2, everything in this column gets +3, everything in this column 0, then -1, -2, and -3. But this one kind of has them down as ions. Not many periodic tables do this. I want to focus on the transition metals. And the transition metals are all these down here and even here under the line of the metals and nonmetals. So I'm going to go ahead and focus in a little more. You'll notice that a lot of these elements here have more than one what we call oxidation state. An oxidation state is a charge. Um, we use it more than just for the charge. That's why there's a term called oxidation state. Some elements only have one charge, zinc, silver. Zinc is always a +2 ion when it forms. Silver is always a +1, just like all the column 1 elements, right? Zinc, like all the column 2 elements. They always get that charge. But there's a number of them that don't have that. I mean, that have more than one possible charge. Sometimes copper has a +2 charge. Sometimes copper has a +1 charge. Really depends on how many electrons you're able to take it away from it. Sometimes nickel has a +2. Sometimes nickel has a +3. We saw iron has a +3 and a +2. Sometimes iron will have a +4 and sometimes a +6. So these are all the only the two most common ions in some of these guys. Chromium +3, +2. Suffice it to say that there is no transition metals are complicated in the sense that there's no rules for us to figure out what the charge would be. And even if we can come up with a rule, it's not related to the column because there's more than one charge for some of these. Some of them there's maybe even 3 or 4 possible charges. And once again, these are only the most common ones. So how do you figure out transition metals? Well, it's so, I mean, maybe your college professor will have you memorize some of these. I'm not going to have you do that. But what we will do is we'll go ahead and tell you what the charge is by not only calling them an iron ion, but which of the 2 iron ions are they. And we will do that by using, as you can see right here, if you look at iron that I'm pointing to right here, we are putting a Roman numeral in parentheses after the name of iron. So iron 3 represents the 3 positive charges on iron. Iron 2 represents the ion with only 2 positive charges. And if you look at that, that's the pattern that we use for all these. Manganese here with 4 positive charges, we call it manganese 4. In case you didn't know, in Roman numerals, the number 4 is I and V. I stands for 1, the V stands for 5. The fact that the I is in front of the V means you take 5, subtract 1 from it. That gives you a 4. That's how you would write 4 in Roman numerals. Vanadium 5 right here, well, that's got 5. 1, 2, and 3 are just like little capital I's. So manganese 2, chromium 3. So that's how I would say them. This is palladium 2, and then this is palladium 4. IV once again is 4. So the general rule is you use these Roman numerals in ions of elements that have more than one possible charge. Now technically, you're supposed to then go ahead and know that zinc, you don't use a Roman numeral for zinc because zinc only has one possible charge. And technically, you're supposed to know that and have memorized that you have zinc has a +2 charge. That silver is not called silver 1, it's just called silver ion because it has a +1 charge. So technically, and in a college class, they'll have you do that. But for our purposes, I'm not going to have you do that. I will take silver 1 or silver ion, because silver ion is correct, but silver 1 would follow the rule. So basically, here's the deal. The rule for an ion of a transition metal, and that starts from column 3 all the way to these guys all the way down below this line. Even these guys right here in column 16, like polonium, bismuth, and antimony in column 15. You would just say the name of the element and the Roman numeral to tell me what the charge is. Okay, so right in the name, it tells you what the charge is. And notice the charges are always positive. Okay, this is easy because we're telling you the charge. I know a lot of students have trouble with it, and I really don't know what the block is. If I tell you that you have cadmium 2, then you know that cadmium has 2 positive charges on it. If I tell you have cobalt 3, then cobalt has 3 positive charges. When you are naming them, if you are given this symbol, PB with 2 positives, you find out what PB is. It's lead. And how many charges are in there? 2. So you put Roman numeral 2. It's that easy. Okay. This lead with 4 positives is named lead 4. And you got to put the Roman numeral 4 in parentheses. We're going to use these names when we're naming stuff. So later on, you're going to have copper 1 oxide versus copper 2 oxide, or cobalt 3 chloride versus cobalt 2 nitrate. So you need to know what the charge is on these guys. And that's where you bring in the Roman numerals. Okay, and when you're saying the name, you just say the number right after that. Okay. Once again, you could give me silver chloride. Or if you give me silver 1 chloride, I'll accept that too. Or zinc 2 oxide will work, or zinc oxide, because technically these guys shouldn't have Roman numerals, but I'm going to make a blanket rule. Anything that's considered transition metal, from column 3 all the way down to the underneath this metal, non-metal stair-step line, will be a transition metal. And we use Roman numerals in the name to show how many positive charges there are. And from that name, we can figure out the number of positive charges. From the positive charges, we can figure out the name.